Random variables. What are random variables? A random variable is a numerical value determined by the outcome of an experiment. Okay, so you know that random variable is a number which is determined by the outcomes of an experiment. So I think the definition isn't enough to understand the basic idea of random variables properly. So let's see some examples. In example 1, we see that you're rolling 2 dice and x is the sum of the numbers that appear. Here the x is the set of random variables that is defined as the sum of the numbers that appear. All right, so here x is expressed in set builder method, where we see that it consists of all smaller x's, where small x equals to d1 plus d2. Okay, where d1 is the number showed by the first die and d2 is the number showed by the second. All right, so d1 plus d2 is small x, so all such small x comprises the set capital X. Now you know that the minimum sum possible is 2. How? Because this minimum possible outcome from one die is 1. So 1 plus 1 is 2. So this is the minimum sum. And the maximum possible sum is 6 plus 6, which is 12. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 are the elements of my random variable set X. Here, how does this X satisfy the definition of the random variable? Okay, so you see that the elements here 2, 3, 4, 5, 6, all of these elements are found by adding the outcomes of our experiment. Okay, the outcomes were the result from the first die and the second die. All right, so these numerical values 2, 3, 4, 5, 6, 7, 8, 9, 10, all of these values are dependent on the outcomes of my experiment, which was rolling 2 dice. Therefore, we can say this satisfies the definition of random variable. So now you know that X represents the set of all random variables and small x represents any particular element of my set of the variables. Now let's go to the example 2. In example 2, we are rolling a die until a 4 appears and let X the number of rolls we need. Now you know that 4 can show up at the very first roll. If we're lucky, it can show up at the second roll or the third or fourth. But you cannot guarantee that 4 will show up by this number of turns, like n number of turns. It can happen that you have been rolling this die for hundreds of thousands of times and no 4 shows up. Okay, so therefore the set of the random variables X equals to 1, 2, 3, 4, 5, 6, and it can have all positive integers in it starting from 1 to infinity, right? Okay, so yes, if the question asks you to find out P of X equals to 5, what does it mean? It means that if you roll a die until a 4 appears and define the random variable like this, then we are interested in finding the probability of rolling the first 4 at 5th turn. Okay, so since you are listing the number of rolls required to get the first 4, therefore you're interested in finding the probability of rolling the first 4 at the 5th turn. 5 for x equals to 5. Okay, so let's see example 3. In example 3, you're flipping a coin 10 times and x is the number of heads we get. Okay, so you know that the minimum number of heads found from 10 flips is 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are the elements in the random variable set where x is defined as the number of heads got from 10 flips. Now, my question to you is, can you tell me what is the probability of P of x equals to 8? That means, what is the probability of getting exactly 8 heads out of 10 flips? So that is my question to you, and you have to solve it on your own. In example 4, we are drawing 16 cards out of a deck, of course randomly, and x is the number of clubs we get. Okay, so you have to find the random variable set X on your own here and also find its cardinality. Okay, and also P of X less than 16, which means if 16 cards are picked randomly from the deck of cards, what is the probability that the number of clubs you get is less than 16? pretty tricky problem, you can use the probability of complements to lessen your effort. So in this case, as mentioned above, you see that X is the set of discrete random variables. Okay, all of the X's contains discrete elements like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sometimes we simply omit the word set here while talking about X, and we say that capital X is the discrete random variable instead of a set of discrete random variables. Okay, it means that there's a finite or a countable sequence of possible values in X. On the other hand, if we define a set of a random variable like the height of a person, so you know that a height of a person can be continuous, like a person can have a height of 5 feet 10 inch, another can have a height of 5 feet 10.001 inch. So these elements in the latest set are not discrete. So this kind of set are referred to as a continuous random variable set. In discrete mathematics, we are interested in the discrete random variables and their probabilities. Now let's go to distributions for random variables. Distribution. The distribution of a discrete random variable is described by giving the value of p of x for all values of x. Suppose capital X is a set of random variables where small x denote the elements in it. Now, if we start plotting the probabilities for each of the random variables in a table like this, then we call it the probability distribution, or simply the distribution for the random variable x. Okay, so in each case we only give the value of p of x when p of x is greater than 0. So say for an element of the random variable set, the probability is 0. So we don't usually put these probabilities in the table. So therefore the values that are only mentioned are greater than 0. Now distribution is sometimes referred to as probability distribution. So let's solve an example and have a better view of distribution. So in this question, you're rolling two dice and x is defined to be the sum of the two numbers appeared. So find the probability distribution for x. Now the first job that I have to do is to determine the random variable set. Okay, so we have determined the set x before in the example of random variables. So we know that x has 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 in it. Now what's next? So I have plotted all the outcomes here. So there are 36 possible outcomes. Now putting the values of x in the horizontal row of this table and using the table of outcomes, it's very easy to determine the distribution. Okay, so you see that the probability for each of the random variables are put here. Okay, so how did I determine these values? Let's see. So say we are going to determine p of x equals to 5 equals what? This means if you roll two dice, what is the probability that the sum of the both dice will be 5? So you see the blue diagonal here? Yes. There are 4 ordered pairs in it, representing the result from both of the dice, and each of the ordered pairs elements add up to 5, right? 1 plus 4, 5, 2 plus 3, 5, 3 plus 2, 5, and 4 plus 1, 5. And no other ordered pairs have the same sum. Okay, so there are 4 outcomes where the sum of the results is 5 and the number of total outcomes is 36. Therefore, the probability of x equals to 5 would be 4 by 36. See, we have put 4 by 36 here, right? Similarly, we have determined the value of p of x equals to 4. Say it's 3 by 36. How so? You see that this diagonal here has the 3 outcomes where the sum is 4, right? 1 plus 3, 2 plus 2, 3 plus 1. So 3 divided by 36 is the probability of getting the sum 4. In this way, we have prepared the whole table. I hope you can do it by yourself. And this chart is called the probability distribution for x. Let's see next example. Suppose A and B are two wrestlers. In a single match, both of them have equal chance of winning, and there's no tie in this form of wrestling. They're fighting each other in a 6-match tournament. So Y is defined as the number of match won by A. Find the distribution for Y. Okay, so you see this is A, this is B, and they're fighting. We'll start with finding the set of random variables. So we'll start with defining the random variables. Okay, so we know that the number of minimum match won by A is 0, and then it can be maximum 6. Okay, so 0, 1, 2, 3, 4, 5, 6 are the number of matches won by A. Let P is the probability of A winning a match. Therefore, 1 minus P is the probability of A losing the match. In other words, is the probability of B winning the match. Okay, since there's no tie, now the chance of winning for both A and B are same. Therefore, P equals to 1 minus P. So by solving this simple linear equation, we get P equals to half. So the probability of A winning a match is half, and for B, it's also half. What's next? We're going to determine the probability corresponding to each of these random variables. So now from binomial distribution formula that we've seen in our last lecture, we know that the probability of A to win exactly R matches in an N match tournament equals to NCR P to the power R1 minus P to the power N minus R. Alright, I hope you remember it. We have to choose any R match from N matches where we want A to win, and then if the probability of A winning in a single match is small p, it has to happen for R times. Therefore, R number of P needs to be multiplied, which will give us P to the power R. And then in the remaining matches, A has to lose. So 1 minus P is the probability of A losing, and it needs to happen for N minus R number of matches. Right? I hope you understood it well. Now here, N is 6 for the question. Total number of matches or total number of trials is 6. And R, in this case, we can say that R equals to Y, right? Small y. So equals to 0, 1, 2, 3, 4, 5, and 6. Right? So for all these R's, we have to determine the values of the probability. Now for P of Y equals to 0 means probability of A winning no match against B. Now you have to choose 0 out of 6 match where A will win. Therefore, the probability of A to win equals to half the power raised to 0 and 1 minus half to the power 6 minus 0. So this is the probability, which becomes 1 by 2 to the power 6. Right? For the next case, we want A to win exactly one match out of 6. So we can choose any one of the 6 matches, so 61 times probability of A winning again to the power 1, and then 1 minus half is the probability of A losing for the remaining 5 matches. Right? Therefore, the answer would be 6 by 2 to the power 6, which would reduce to 3 by 2 to the power 5. Then for the rest, what would be P of Y equals to 2? 62, any 2 match from 6 matches, half to the power 2, and then 1 minus half to the power 6 minus 2. So it will become 15 divided by 2 to the power 6. 2 to the power 6. Okay, so I want you to find the remaining 3 probabilities by yourself and then put these values. Let me put the first 3 values here for you. 1 by 2 to the power 6, 3 by 2 to the power 5, and then 15 by 2 to the power 6. Okay, if I'm not wrong in the calculation here, let's check again. 6 into 5, 30 divided by 2 is 15. So here 2 to the power 6, yeah, I'm right. Now you have to put the values of 3, 4, 5, and 6. Sorry, there's another case missing here. P of Y equals to 6. Okay, which means that probability of A winning all the matches against B. So you have to put these 4 values of probabilities in the box. So this is the distribution for the second problem. Let's go see another. Oh, I have an exercise for you. It states that suppose in November, the probability of raining in a day is 0.1. The question 1 asks you that what is the probability to not rain in a day then? Okay, it's very simple. You know what to do for complement events. For the second question, you are asked what is the probability that there are exactly 5 rainy days in November. So you have to keep in mind that there are 30 days in total in November. In the third question, X is defined to be the number of rainy days in the first week of November. So you have to find the probability distribution for X, which will have 8 elements in it, right? In the first week, there can be no rainy day, or 1, 2, 3, 4, 5, and at max 7 rainy days. So you know how to solve this problem. Do it by yourself. Let's see our next example. This example is on geometric distribution. Suppose the probability of success in an experiment is small p again, you are running the experiment repetitively. X equals to the number of trials required. Find the probability distribution for X. Okay, so X is the number of trials required for one success. Okay, you have to keep that in mind. It's one success. So therefore, if you get the first success, you will stop trialing. Now for the solution, we have to determine the set of the random variables again. So what are the possible scenarios? The number of trials required to meet the first success starts with 1, and it can be up to infinity, right? You cannot guarantee that by, say, 1000 number of experiments will meet success with 100% guarantee, right? Well, so we know that the probabilities corresponding to X can be found using geometric distribution formula, because for any number of trials, say it's n, required for one success, we need n minus 1 failures at first and then a success at last. So the probability to get the first success at nth turn equals to 1 minus p to the power n minus 1. These are contributed from n minus 1 failed trials, and then the final p comes from the success. So now we know that for n equals to 1, p of x equals to 1. That means the probability that you meet success at the very first trial, it would be equal to 1 minus p to the power 1 minus 1. We have to put the value of n equals to 1 here for 1 into p, which becomes p. So this is the probability to succeed at the very first trial, right? Now for n equals to 2, what is p of x equals to 2? P of x equals to 2 means what is the probability that you are required to run 2 experiments to see the first success. So you see 1 minus p times p is the probability to succeed at the second trial. Therefore, n equals to 3 will give us the value 1 minus p squared times p. Similarly, for any number of trials n, we get 1 minus p to the power n minus 1 times p. Now putting these probabilities here in the table, we'll get the distribution. Okay, so I hope you understood distribution well.